The topic that we have to cover is torque of a couple. Basically, couple is, should say there, when two equal and opposite forces, when two equal and opposite forces which are not in line act on an object. When two equal and opposite forces which are not in line act on an object, then the net force becomes zero as the forces cancel out, yet the net moment will not be zero as the forces are not in line. So whenever you have two forces which are equal and opposite but they are not in line, then they make a couple, and a couple causes the rotation of an object without creating any acceleration. So the net force is zero, yet the net moment is not zero because the two forces are equal and opposite but not in line. So for two forces to be perfectly in equilibrium, they must be equal, opposite, and in line. Here in this case, the forces are equal and opposite but not in line. That will result in the rotating effect or the moment. So if we want to represent a couple, basically the idea is whenever an object is acted upon by two forces, just for example, if this force is F and this other force is also F, and the distance in between is, for example, D. The distance in between is, for example, D. Then this makes a couple. These two forces make a couple. And in this case, if you care about net force, the net force will be 0 Newton, while the net moment, the rotation is there. Net moment is not 0. So a couple causes the net moment without any net force or acceleration. How will you calculate the torque of a couple? You'll write to calculate torque of the couple, one of to calculate torque of the couple, one of the forces must be multiplied with the perpendicular, one of the two forces making the couple must be multiplied with the perpendicular distance between the forces. In the above example, if we go for figure 1, this is figure 1, we can say that in figure 1, a couple is shown in which there are two forces which are equal and opposite but not in line. So in figure 1, torque of the couple is equal to multiply F with D. We are using D because it is perpendicular. This is the perpendicular distance. In some cases, you will be asked to calculate torque of a couple and the distance that would be given will not be perpendicular. For example, if this is the shape of an object and it is acted upon by two forces which are equal and opposite, yet the distance between the forces which is given is not the perpendicular distance. For example, this distance D is given. And the angle of D, some angle would be given. For example, the angle of D with this force or the other force would have been given. So these are the two forces. For example, this angle is theta, and they ask you to calculate torque of the couple, and they have given you the wrong distance. The distance must be perpendicular. Then what you will do, you will extend the line of action of one of the forces, you'll draw a perpendicular, and you'll call that, just for example, x. First, you will calculate x. So if you want to calculate x, it would become, this is theta, this is 90 degrees, this is x. So sine of theta could be written as x over d, and x will be d sine theta. Now you are able to calculate x, that is a perpendicular distance between two forces. As a result, the moment would be multiply one of the forces with perpendicular distance between the forces. Multiply one of the forces with perpendicular distance between the forces. So it can also be written as this torque of couple, which is actually the net moment. So torque of couple in the above example could be written as F times perpendicular distance is d sine of theta. So this is the concept for torque of the couple.